Hello, students. Today I'm going to illustrate the advanced function grade 12 for this textbook and Hugh Ryerson for chapter 2 and unit 2.1 on page 85. The polynomial remainder theory. So let's start. Open the book and do the example and exercise. So all the grade 12 advanced function, the concepts are the same. You learn the skill here, you can apply to any grade 12 advanced function book. Example 1. Divide a polynomial by a binomial. So divide negative 3x squared plus 2x exponent 3 at ax minus 12 by x minus 1. So we are going to write into a division format. So when you write division, you always write the largest exponent in front. It becomes 2x exponent 3 minus 3x squared at 8x minus 12 divide x minus 1. Now I'm going to show you how to divide it. Now when we start to divide it, we think about to get the x exponent 3. So if like that, we're going to try x exponent 2. So to cancel the first leading degree and the coefficient. So I will try 2x exponent 2. So 2 times x is 2x. And x exponent 2 at 1, you get 3. You get 2x exponent 3. Now 2 times negative 1 will be negative 2x exponent 2. So now we subtract it. So when you subtract, you cancel these 2. So you're going to negative, you get a positive here. Negative 3, positive 2, we have a negative x squared left. Now we bring down the second term, is 8x. Now we only need to consider cancel the first leading degree and the coefficient. So we're going to try negative to cancel negative and try x. So negative x times x, we're going to have a negative x squared. And negative x times negative 1, we have a plus x. Now from here, we're going to subtract it. When you subtract, you cancel the integer. So 2 negative, you get a positive. Positive, negative, you cancel this term. And negative, positive, you get negative. And positive a, negative 1, you're going to get positive 7x. Now we bring down the last term, negative 12. So we only need to consider 7. So we're going to add 7, the leading. 7 times x, we get 7x. 7 times negative 1, we get negative 7. So in here, we're going to subtract. So when we subtract, we cancel the opposite the integer. So positive, negative, positive, we got the negative here. So negative, we cancel. If I put a bracket. And negative, we get positive. So 12 minus positive 7, you're going to get a negative 5 as the remainder. So when you get the remainder, how are you going to write the equation? So you're going to write the original one. It will be negative 3 x exponent 2 plus 2x exponent 3 at ax and minus 12. So divide, we write it into a fraction, x minus 1. And then what do you get? The answer is, excuse me, I forgot to move the camera down. Okay, so we write the original function and the division. Yeah, fraction is a division. We write the answer at next. So the answer is 2x squared minus x is 7. So we're going to express the 1 for a remainder. So we add back the negative 5 over the divide e, x minus 1. And that's how to express it, the remainder. Good. The original function and divide x minus 1 and the answer is the remainder. And that's for the example 1. I'm going to explain to you the example 2. Now, example 2 on page 86. The original function f and x equal 4x exponent 3 at 9x minus 12. So we got to write it in a division format. When we write x exponent 3, so we need to fill in by order the exponent. So 0x exponent 2 and plus 9x minus 12. So every time you're going to fill in the exponent by order 3, 2, 1. Good. Now, we're going to try the first number. Always cancel the first term. So we're going to try 2. So 2 times 2, we get 4. And how about x exponent 3? Then we try x exponent 2. So now we're going to times it. So it becomes 4x exponent 3. And 2x squared times 1. It's going to be plus 2x squared. And from here, we are going to subtract. So when we subtract, we cancel the integer. So negative, positive, we cancel the first one. And these become negative. So we're going to get a negative 2x squared. Now we bring down the next term is 9x. So we're going to cancel the first leading. It will be negative. So we times negative. It's negative 2. We're going to put the x here. So negative x times 2x, we get negative 2x squared. And negative x times positive 1, we get negative x. And from here, we subtract it. And negative, negative, positive, we cancel the first term. And negative, negative, positive, we get a 10x. And we bring down the last term. The last term is negative 12. And we're going to try a positive 5 here. So 5 times 2x, we're going to get 10x. And 5 times 1 will be positive 5. So we subtract it and cancel the integers. So times the negative sign to opposite the integers. Excuse me, negative, positive, we cancel. And negative, negative, we get a negative 17 as the remainder. Now we got to write the answer. So for the function 4x exponent 3, my plus, excuse me, is a plus. We got it here. So divide 3x at 1. And what are we going to get? We write the answer. The answer is 2x exponent 2 minus x at 5. And then plus the remainder is negative 17 and over 2x minus 1. And that's how you present the remainder for the factor theorem. So, and then what else we're going to do? We need to write the registration for this divide e. So you're going to write x is not equal negative 1 over 2. We just solve this x-intercept. X is not equal negative 1 over 2. And that's how to divide a fraction. So x is negative equal negative 1 over 2 for example 2. We are going to continue for the next example. Example 3 on page 87 is a problem solving. So it's giving you a rectangle prism and giving you the volume and giving you the height and asking you find the dimension for the base. The base, we have a L and a width. So L and W. So how are we going to do it? So we take the volume divide the height. We're going to get the base area. And that's the formula. So we're going to write V divide the height over H is going to be equal the base area. So this is the equation we are looking for. Now we put the V in a division box. X exponent 3, 8, 7x exponent 2, plus 14x plus 8. Now we're going to divide the height x at 2. So the first one we're going to get is try x exponent 2. We get x exponent 3. So add 2x squared. So we subtract it. So when we subtract, we times the negative sign to change the integer. Positive, negative cancel. Positive, negative, positive, we get a negative. We're going to get a positive 5x squared here. Now, and then add 14x. So bring down the next term. We're going to try 5x. So add 5x. 5x times x, we get a 5x squared. And then 5x times 2, we get a 10x. So from here, we subtract it. So we times the minus sign. So positive, negative cancel. Negative, positive, we get negative. So we're going to get a positive 4x. So we continue bring down. The last term is an 8. So we're going to have a 4 here. So 4x and then plus 8. Wow, it just fit. It's equal 0. It has no remainder. Now we get the base area. So it's equal x exponent 2 plus 5x plus 4. So from here, we're going to get the room here, some space, to factor this base area. So we have an x squared at 5x at 4. So, and then we factor it for x at 4 times x plus 1. So from here, we get the base area, one called length and one called width. So therefore, now we find all the dimension for this prism. So for the base area, for the base, L, it's equal x at 4. The width is equal x plus 1. And then the height is provided. So it's equal x plus 2. So for this L times W times height, you're going to get this volume. So therefore, the equation here, so we are going to get it's equal x plus 2 times x plus 1 and times x plus 4. So it's going to be the L, the W, and the H. So 3 times together, you get the volume. That's how we solve it. Use the volume, divide the So we are going to do example 4. Wow, a lot of natural sunlight. I love it. Now we look at the page 89, example 4. So apply and verify the remainder theorem. So given the function p at the x is equal to x exponent 3 at x exponent 2 minus 3x minus 6 divided by x at 1. So you're going to verify it just by plug in. So when x at 1, it means solve this x-intercept. So x is equal -1. So we're going to plug in x -1 here. So we're going to get 2 times -1 exponent 3 and times -1 exponent 2 and -3 times -1 and minus 6. So you're going to get the answer. It's going to be -2 and here +1 and +3 and -6. And you're going to get a -4 as the remainder. So it's going to be now if -4 is a remainder, we are going to verify with a long division. So I'm going to do the long division here. So we write the function inside 2x exponent 3 x squared minus 3x and minus 6. So when you divide it, you write the full bracket here. So x at 1. Now, when divide x at 1, we first consider cancel the leading. So we're going to have a 2x exponent 2. Then we're going to get 2x exponent 3 and 2x exponent 2. So we minus it. So minus minus positive, we cancel 1. This become minus. We're going to have a negative x squared left. Continue. Bring it down the next term. We're going to cancel the leading. It will be negative x. We get a negative x squared minus x. Now we're going to subtract it. So negative, negative, positive, cancel the first one. The second one will be negative 2x. Continue bringing down 6. So we're going to try a negative 2. So minus 2. We have a minus 2x and minus 2 here. So we subtract. So when you subtract, you cancel the first leading, and this becomes an 8. The remainder is -4. Still remainder, the same value as the substitution remainder here, a -4. Now, we're going to try the next method. For part C, the book is given compare 2x minus 3. So it's going to be giving you another factor. So it's for the C part. The factor is 2x minus 3. So 2x minus 3, if you solve this intercept, x equals 3/2. So if x equals 3/2, so we are going to find the remainder. So we continue substitution into the p at 3/2. So it's equal to times 3/2 exponent 3 at 3/2 squared minus 3 times 3/2 and minus 6. So what are we going to get? So we're going to get 2 times 27/8. And then add 9/4. So, and then add here is minus 9/2. So, and then we're going to get the last part is a minus 6. So we continue simplify. I'm going to move it for the second page. Now we continue to do simplify. Times 2, we cancel this become a 4. So, and then we're going to change them into the same denominator. Let's say this one times 2, we get 4. And 6, we're going to write it into a fraction, 6/1. Need to times 4. Now we're going to write the new fraction. Will be 27/4 and 9/4. 9 times 2, negative 18/4. And 6 times 4, we get 24/4. Now from here, we're going to add the numerator and subtract the numerator. So what are we going to get? So we get 6/4 negative. Now 6/4 negative, it means equal negative 3/2 is a remainder. Now we continue example 5 on page 90. So solve for an unknown coefficient. So you're given a polynomial 3x exponent 4k. So k is the unknown coefficient. I underline it with the highlighter. So x exponent 3 minus 7x minus 10 is going to be divided by x minus 2. The remainder is an 8. So how are we going to do it first? We're going to plug in. So for this equation, so if the x divided by 2, so we're going to put x2 as a positive 2, solve this intercept. So x equal to, with substitution into the polynomial. So 3 times 2 exponent 4 and k times 2 exponent 3 minus 7 times 2 and minus 10. And you know the remainder is an a. So we set up the equation like that. So and then we try to solve it. And there's only one variable here. Of course, we can get k equal how much? So we're going to put 3 times 16. So we're going to get a 48 here. So plus 8k. And then minus 14, minus 10, we get 8. So we combine all the number in the right side. We're going to get 24. So 24 and 8k equal 8. So 8k is equal a subtract 24. So we're going to solve k here. So k is equal negative 16 divided by 8. And then k is equal negative 2. And this is the final answer. Solve the unknown. By substitution, the divide factor 2 into the equation and set up the remainder as the equation and solve only one unknown. That's how we do it. So simple. And we finish for the entire chapter unit 2.1 explanation. So, and this is our Smart Kids Learning Center tutoring class. For explanation, the chapter 2, unit 1, and this is our contact number, and our majorly tutoring all the high school math, specific for advanced function grade 12 and calculus, as well as English. And please subscribe our video. And I'm going to continue explain you for the next unit, for unit 2.2 in the next video. Thank you. Bye-bye.